All right, so in this next video, we are going to be foiling a lot, okay? And I want to see if you guys notice some of the patterns that I notice when we go through these, okay? So we'll maybe just do maybe one column at a time or one row at a time here. I haven't decided yet. And we'll just sort of see how this goes and see if we can realize some patterns. Okay, so at this point we should be pretty good at foiling. So I'm going to start top left here. Okay, first times first here is just going to give me x squared. Okay, the outside times outside will give me a negative 2x. Okay, inside times inside will give me a positive 2x. And then last times last will give me a negative 4. Okay, when I combine like terms here, I notice that these two actually cancel out. So x squared minus 4 is my final answer. Okay. In this next one, I'm going to rewrite this a little bit differently. This is the quantity of x plus 3 squared. This is not, I repeat, this is not x squared plus 9. Okay? Remember, what this actually means is this is x plus 3 multiplied by x plus 3. We have to FOIL this problem. Okay? So I'll take x times x is going to give me x squared. I'll take x times 3 is going to give me a positive 3x. 3 times x will give me another positive 3x. And then 3 times 3 is going to give me a positive 9. When I combine the like terms here, 3x plus 3x, it's going to be 6x. So I get x squared plus 6x plus 9. Okay? So again, tough to see patterns when we've only done a couple. But again, we're looking for major patterns in the columns. Okay? So z minus 2, that quantity is being squared. Remember, this is now z minus 2 times z minus 2, right? And so if we FOIL this, we'll get z squared. Outside, we'll get minus 2z. Inside, we'll get another minus 2z. And then last times last, we get a positive 4. And so if I combine like terms here, I have negative 2z plus a negative 2z is going to be negative 4z. So I'll get z squared minus 4z. Plus 4. Okay, well, not seeing anything major yet. Obviously, we're kind of comparing some different ones here, but let's maybe scroll down and give a few more a shot. Okay. In this next one, I'm going to FOIL this. First times first, give me a 4n squared. Okay. Remember, we multiply the coefficients first, then the n's after that. The outsides in this case, I have 2n times negative 3. That'll give me a negative 6n. The insides will give me a positive 6n. And then last times last here will give me a negative 9. All right, so if I combine like terms here, those are opposites, so it'll just cancel out. So I get now 4n squared minus 9, and that is going to be my simplified expression. Okay, let's check out the next one. I have the quantity of 3m plus 1, and that's squared. So I'm going to rewrite this as now 3m plus 1 times 3m plus 1. Now I will go ahead and FOIL this here. So I'll get now 9m squared. For the outsides, I'll get a positive 3m. For the insides, I'll get a positive 3m. And last times last, I'll get plus 1. When I combine like terms in the middle here, I'll get 9m squared plus 6m plus 1. Okay, again, I encourage you to take notes along with me here. Okay, this next one, I'm going to rewrite this as the product of two binomials. So this will be 6x minus 4 times 6x minus 4. Okay, when I FOIL here, I'll get 36x squared times a negative 24x, minus 24x, excuse me, and then negative 4 times positive 6x will give me another negative 24x, and then last times last year will give me a positive 16. So when I add those like terms in the middle there, I'll get 36x squared minus 48x, and then plus 16. Okay, so let's see if we can see any common themes yet. I sort of see maybe one major thing is that in the left-hand column here I have binomials, okay, only 2 terms. The other ones I have trinomials, which are 3 terms. Let's see if our pattern continues here in this last one. Okay, so 4t times 4t is going to give me a 16t squared. I now have 4t times 1 is going to give me a positive 4t. And it looks like this pattern is going to continue. A negative 1 times positive 4t is going to give me a negative 4t. And then last times last will give me a negative 1. And if we add these terms up in the middle, the t term, they'll cancel out. So my final answer is 16t squared minus 1. Interesting. Okay. If I continue here, I'm going to write this now as 5s plus 2 times 5s plus 2. Again, I'll go ahead and FOIL this here. I'll get 25s plus 10s plus 10s. These numbers in the middle kind of seem to be matching all the time in this column. And then last times last here, I'll get a positive 4. Okay, so when I add these together, I'll get 25s squared, excuse me, sorry I missed the squared, plus 20s plus 4. Interesting. Okay. And then finally, this last one here, 5p minus 7 squared. I'll write this as, again, a couple of binomials, or the product of two binomials. I'll go ahead and FOIL to get 25p squared minus 35p. And again, these numbers in the middle keep matching here. Minus 35p again, and then negative 7 times negative 7 is actually going to be a positive 49. Okay, and when I add these numbers up, I'll get 25p squared minus 70p plus 49. Okay, now one thing I'm noticing here, and this is on all of them, is that the first and the last numbers for our coefficients, if you want to call them that, they're all perfect squares. Noticing all these numbers right here, 16, 36, 1, 9, 1, 9, 1, 4. They're all perfect squares. Okay. In this left-hand column, I only have binomials, so that's sort of interesting. Looks like the n term or the t term or the x term drops out. Okay. And we kind of notice a common theme here in the middle. It's sort of, they double, like 10s plus 10s is 20s, and negative 35p plus another negative 35p is negative 70p. So let's see if these patterns persist. And I challenge you to try to actually write the pattern out if you see it. In the next video, we'll definitely go over what that pattern is.